All right, welcome everyone. So we are here to chat about how to add GitLab managed apps. And for some context, this has come up in two separate places. The first place was when the Defend team was going to add a web application firewall. In the end, that didn't materialize into a GitLab managed app because instead it was done piggybacking up the existing Ingress app. And then the second one is one for Elastic, that is one that we have an open MR for. So I thought that here we could walk through first how to add a GitLab managed app. We kind of have an existing way of doing that. And the orchestration group has a new way in we're picturing how the future of GitLab managed apps will look like, which is CI based. So I thought that we could start with the existing one, and Tong is going to walk us through basically how it's done with help of the other members here. So Tong, do you want to take it away?
All right, cool. I'll probably share my screen. That probably makes the most sense. Is that too small, or is that all right?
It's a bit small, but it's readable. I think that if you're going to use anything outside of the browser, it's better to share the whole desktop.
Right, let me switch to a smaller screen instead of the giant monitor. That one. Okay, that's probably better. So the easiest way I thought would be to just use the existing merge requests for Elastic to kind of walk through how to add a new GitLab managed apps. It seems reasonably complete, and James has tested it out. So it's probably a good example, the most recent example anyway as well, so which is good. So in terms of GitLab managed apps, after you've added or created a new Kubernetes cluster, you get a screen that has a few applications that you can install, including Ingress or Cert Manager or even Knative. And here's a screenshot of Elastic Stack as a GitLab managed app that you can install. Note that it has a configuration option of keeping a hostname. That's the only one configuration option it has. Other apps won't even have any configuration options. They're all default. So major changes. It's if we start from the database up. We basically have a table each for each type of GitLab managed app. And it's pretty standard tables. You can refer to the current existing tables. So, and once you have that table to kind of keep track of what app is installed, it's got a state management as well to say is something currently installing or not. And that's done inside the models. So having its own Rails table, it has its own model as well. And if you look inside cluster status, cluster concerns application status, you can see what kind of the state machine looks like, really. Yeah, let me think. Yes, so that sets up the models. Now, and that's pretty easy. Now, how this works is basically then we use Helm to install GitLab managed apps. So, and each GitLab managed app is basically a Helm chart really that you can install. And we have some helper kind of classes to create the Helm commands to install applications. So this one specifies that the name of the chart that you want to install it on, the name of the release. So you have a chart called Elastic, and then you can name it whatever you like. And here we're naming it Elastic-stack. So it's a fixed thing. And what version of Elastic we want to install on, whether it's RBAC or not. And that's actual chart. So the chart is stable/Elastic-stack. We're over here. You can also install Helm charts from other repos as well. We just need to specify the the repo that you want to install it from, if it's not from stable, that is. So for example, let's look at example for repo. So applications, when we look at Cert Manager, for example, so Cert Manager is not hosted on stable, it's hosted on the JetStack repository. So here we're specifying that's the JetStack repository. And I think we're calling the JetStack repository Cert Manager. Yeah, so that's how you specify a different repo. So this command basically generates a whole array of shell script commands, and this shell script command then gets sent as a list of shell scripts to be run on the pod. So we don't, GitLab doesn't install the Helm applications itself. What GitLab does instead is that it creates a bare pod on the user's cluster, and that bare pod gets run that bare pod gets run to install those apps. So it runs those commands to say, get the repo, get the Helm repo, install the application, and so on and so forth. So,
so is there a reason that Helm isn't just used directly?
Directly?
Oh.
I think it's twofold. I think one is the permissions might not allow it, and secondly, we try to limit as much kind of direct interaction with the cluster as much as possible, because we don't know whether that's truly a Kubernetes cluster or not. So there's kind of security concerns there as well. So ideally, we run it on their cluster instead.
And would this change with Helm 3, this approach?
With Helm 3, I think it would be the same approach, really. Yeah.
Cool.
Yeah. Because we don't want also, basically, Helm, if we Helm 3, instead of running some sort of tailor, and tailor installs the app on their cluster, we basically run the Helm client somewhere. I don't think we want to run the Helm, GitLab. I don't think GitLab, the application, the Rails application, will necessarily want to run a Helm binary to go install it somewhere. And remember, the response that we get back could be anything. It's completely arbitrary. We didn't control that at all. So it's probably not that important if you are self-hosting, because you can sort of trust that maybe. But any sort of SaaS, say on GitLab.com, for example, unless we whitelist each and every kind of Kubernetes cluster, it's probably better to continue this architecture, really. Yeah, if it makes sense. Cool. So that installs it, and I'll probably show you how I'll probably run through how it does it soon. But once that gets installed, it goes through a state transition and so on and so forth. And the view, there's a kind of a view layer that will kind of respond to each state. So if it's installing, it will display a spinner, for example, and so on and so. I think so. I'm not too familiar with the view part, but I think the view also replicates some parts of the state machine as well, so that they know what to respond to as well. So that's probably some things you need to look at here too. So unfortunately, so let's have a look at this view thing. So this is one of the reasons why we're looking to go to the CI-based job instead as well, because for every new application you want to install, it's kind of hard-coded. There is no genericization. So every single application is its own view template. There's no genericization at all, and it's getting quite harder and harder to maintain. So yeah, that's one thing. Probably someone who's more interested, who's more familiar with Vue can expand on that at a later stage. Is there a FE in this call? No, that's all right. But it should be pretty easy. You're just extending common patterns that you already see, really. Okay, so before we try this, one other thing is the configuration part. So see this Kibana hostname. So when a user enters a value onto that, how does this value gets passed as a kind of a value to the Helm chart? How that's done is basically this. Each GitLab managed apps has a set of default values that we specify, and it's under vendor application name values.yaml. So in this case, it's Elastic Stack. And these are the kind of fixed values that we specify for that Helm chart. And it's completely non-customizable, as you can see. If you want to customize it, it's possible. What you can do is in the model, you would specify, you will override the values method, and you can override it with whatever YAML you like. So by default, values will get the the values of this file of your values.yaml. But if you want to override it, what you can do is you can say load the values file manually and then merge it with some other things that you want to merge. So in this case, what we're doing is we're getting the default values.yaml and then merging it in with a extra Kibana section where we customize the Kibana hostname. Does that make sense?
Yep.
Awesome. Yeah, so that's about it, really. I don't think I've missed anything. Is there anything else that I've glossed over?
So for something like cert manager or I don't know about, I'm not familiar with this chart. Is there separate handling for something like CRDs? Or is there like...
Okay, yes, that's a good question. So yes, there is. So let's get this one to see if there's anything interesting. No. By the way, you can uninstall. So yeah, there's some uninstallation steps. So let's look at Cert Manager for a better. So with every install command, you can have the ability to specify a pre-install script. So whatever script you like, and a post-install script. And in this case, this is where we take the opportunity for Cert Manager to install the CRD. Yeah. So apply file, I think, is just Q control apply, if I'm not wrong. Yeah, it's control apply basically. Yeah, so this is where we can do it, and we can do post install, post delete, and pre delete as well. Does that answer your question, Lucas?
Yeah. So I'm not super familiar with how something like Helm would do an uninstall, but does Helm generally clean up like resources created during the install, or what? So if I was doing something like applying in this pre-stage, then in the post-stage, I would also have to ensure that the necessary resources are getting deleted as well.
Yes, that's right. Yeah.
Okay.
Yeah. Helm itself has the ability to install CRDs as well. So it's a hook. It's a hook thing. So you say CRD hook or something like that. But the problem is that even though Helm allows you to install CRDs like that, it explicitly states that such CRDs are unmanaged from Helm source-second, so they won't even try to delete it after you try to delete the chart itself. So a lot of people have kind of given up on that and just ask people to manually install CRDs and manually delete it after you're done. And the biggest problem with the CRD hooks is that you can't control, it apparently doesn't detect whether it's been installed or not. So if you install the same Helm chart twice, it just blows up on the second time you install it because it says the CRDs already exist, so which is kind of annoying. I think Helm tree might have some fixes for that, but I'm not sure yet. To answer your other question, yes, Helm generally deletes resources it has created. It knows, yeah, because it it knows that this resource is managed by Helm, so it can also delete it as well, except for things like CRDs and one-off jobs, I think. So if you got jobs, one-off jobs like that, which we don't use in GitLab-managed-apps, then it won't delete it as well.
Cool. And Dylan mentioned something about upgrading and like updating apps. How does the life cycle work for that?
Yeah, I just thought it might be worth sharing how it knows when you can upgrade an app and then what actually happens to upgrade it.
Yeah, that's a good point. So the only current application that we have upgrading right now is Runner. We're planning to add explicit for upgrading for other apps as well, but that's all planned. So currently, what happens is that we have a version number, and every time we have an update to it, we just bump it, and there is no upgrading if you don't have upgrade support. You can uninstall and reinstall again. That's probably the recommended steps. But in terms of Runner, what happens is that let me kind of remember quickly. That's very interesting. The first thing to remember is that we have a version column that stores the version that was installed on the app. So say a few months ago, you've installed Runner, and it stores that I've installed Runner 0.8.0. Now, someone comes along and bumps the version constant to 0.9.0. And what happens is that on the front end, or when we render the GitLab-managed-apps page, which is the cluster page over here, where this page over here, we will say, we'll do a detection to say, is the locked version, is the kind of constant, the same as the database version? If it's not the same, then that means there has been an opportunity to upgrade, and we'll display an upgrade button as well. So let's see whether it's possible to show you as well. Because I have an existing cluster too.
So while you're looking for that, as a more general question, it seems like it would kind of be the same logic for everything. So why is Runner the only one that supports updates right now?
Because we have to test the upgrade cycle to see whether it works. That's the answer.
And it won't work for most of them by default. I think like James has found a lot of stuff that's not going to work for Cert Manager. And we know that Knative has never implemented upgrade properly in their charts. I mean, it's the chart maintainers just not building them in a ways that necessarily makes them upgradable. And the simple things like CRDs or other more complex upgrade challenges. So yeah, we'd have to go through and test every single one, make sure they actually work, and then find that they don't work, and then either try to implement it ourselves or recommend people uninstall and reinstall, or we can't implement uninstall, reinstall automatically because that would be possibly problematic for people that lose resources.
Cool. So thanks, Dylan. So you can see that GitLab Runner has an update button. Probably installed this GitLab Runner a long time ago. So let's click update and see whether it will start updating.
And so this would be happening within a like upgrade runner cluster, or sorry, upgrade runner pod right now.
Install runner pod. We just reuse the same thing, really.
Okay.
Yeah. So let's see what's happening. Get pods. Sorry. So let's list the pods in the GitLab-managed-apps. And you can see there's an install runner pod, this one. So that's the bare pod that we used to install it. And then if we get the logs of the install runner pod, You can see that something's happening and it's errored out. Okay, sure. Follow.
I think that's kubectl erroring out, not getting access to your pod.
Possibly.
Oh, actually, no, it's not because it's got Helm version. Okay, yeah, no, it's Helm erroring out, connecting to Tiller.
Yeah, I think there's an existing Helm issue for this, and I have no idea what's the issue. It looks like they closed it, saying this will fix in Helm tree, but that's kind of unsatisfactory, unfortunately. But maybe that's okay. What's the status of the pod? Running. Okay. But the first thing that we do as well, because we found issues with this, is that the first thing we do is upgrade Helm automatically to the version that we have locked it to. So if you got a Helm 2.12 or something like that, and we currently have Helm locked to 2.14, it will automatically upgrade to Helm 2.14 first. I'm not hopeful of this, judging by the error messages coming out. Yeah, this is not ideal. Chat. Yeah, we use Helm install -- upgrade. So basically we can use it for both install, the first time install, and upgrades as well. This is not ideal. Are there any other ports that we can show as well? No, we deleted it. Okay. So if something has been installed successfully, we delete the install dashboard. If something has errored out, we don't. So this really helps people debugging what's going on, like currently what I'm doing. It might time out eventually. And
so, as a general debugging question, what is the best approach when I get to this point? I don't mean to figure out what the issue is, but to reset or get to a usable state of the application?
I honestly don't know in this case. So there's something wrong with Helm itself. So
it looks like Tiller's not responding, so you would basically want to get onto a pod and do exactly what's going on there, which is it's trying to running Helm version is just basically a ping to Tiller to say what version are you. So if you can get either your local environment or a pod on the cluster with that shell that has the certificates there to connect to Tiller, you can try to figure out what's going on with Tiller. You're probably also looking at the logs for Tiller deploy, because I saw that he had Tiller deploy there running still. It's not dead, so that's a bit interesting that it's not responsive. So that might well have logs saying something about why it's not being responsive to anybody else. No idea what that means.
That's a standard Helm starting up, Tiller starting up. What? Oh, get events. You can also get these events. Scope to namespace. Not sure. You can also get events as well. Oh, there we go. So, so that shows you from oldest to newest all the events that it's done. So it's created a pod, the pod was successful, something. It actually succeeded, strangely. Okay, that is so weird. Okay, so okay, That's interesting. Okay, so this is what's happening. It was trying to upgrade Helm, and it was trying to get the Helm version. And then there was a bunch of errors, which maybe we could ignore. And then what we do is Helm add the repo, because it's the custom repo. It's not part of Helm stable. And then we update. We run Helm repo update to get the latest contents. And then that's the command that we generated to upgrade runner itself to version 0.9.0. Yeah, and you can see that that's the values thing. So we basically pass in the values YAML as a file into the pod as well, so that the command can run, can refer to that file. And it seems like it's successfully updated as well. And okay, it's upgraded. So that should be it. Matt has a note when I work with applications. Adding things to cluster store.js and cluster bundle to get things passed to the backend wasn't super obvious. So might be worth covering if people need to pass any configuration to a chart. Sure, I can try, but I have no clue what it does, honestly. So maybe you want to speak to that, Matt?
I can try. So as far as the front end goes, anything in the front end, like you said earlier, the front end kind of maintains its own state machine, but it also maintains its own state in a as far as like view state, and that's in cluster store. So for everything that for every value that you take, every like configuration value or like a host name, you have to add like a setter method for in order to modify state.
Sorry, do you want to share your screen? Maybe you can see what you're referring to, because I'm not sure what. Would that be all right?
Oh, I don't have anything pulled up on my screen for this.
Okay. You want me to kind of find the line you're talking about? Because
sure.
I've got a cluster store up.
Yeah, so I'm probably not the best for doing this. So like for instance, Knative has a host name, right? So there's Knative host name here, but then you also have to provide a way to set that. So then if you go further down, there's some functions like set help paths, etc. You have to actually build yourself a way to set that value. So there will be something down here for setting the Knative host name.
Somewhere. In this one?
Yeah, so well, this is loading the state from the server, which you also have to do that too. So when you're loading something from cluster status, the cluster status endpoint, so all the data that comes back from the server is in the cluster status endpoint, and you have to set your view state from that for it to show up in the UI. And then further down, there's methods that you call from the UI to actually set variables as well.
I think we reached the end.
Yeah, it might be in clusters bundle.
Clusters bundle. Which is in here too.
Yeah, so line 455 of mine has set Knative hostname.
Set Knative hostname.
Yeah. So that gets called by the front end to actually set this, just the view state. And at some point that actually goes up to the server. I'm not clear on when that actually happens, or if that happens live as part of the cluster store being modified. I think it might.
Yeah, okay.
Yeah, but it's really non-obvious how to get stuff passed to the back end from the front end.
Yeah, so why does this Helm not do the same for Elastic Stack? Don't know, not sure. Potentially that's something front end needs to look at. Because it seems to only have install Elastic Stack path. Interesting. Don't know. That's a good point. Thanks, Matt. So if we look how the cluster status JSON looks like, it looks like this. So it's a bit small. Can we expand it? Yes. So it's got a status that says created. That's the status of the cluster. It's got a list of applications as well. Some of them are installed, some of them are updated. So that's the list. There's a kind of state machine status you get back from the backend. And then, say if you look into Knative, it's got things like external IP, external hostname, things like that. So it's different for. Oh, it's not different. Yeah, interesting. I don't know why we can have external hostname. Oh, I see. Yeah. So Ingress and Knative has extra fields, for example, and Cert Manager doesn't. So that's how cluster status JSON looks like. If I record those null checks, we're there to handle the fact that someone is editing a status point and come back and change the input.
Yeah, so basically, I think the state stuff you just showed and just Matt described is to do with the fact that Knative can have that input changed after you've already performed an install. So you have is editing hostname so that the front end knows when the status endpoint returns with the previous hostname, it shouldn't go ahead and just overwrite the hostname in the UI while you're editing it. So set Knative hostname should only be applicable if to Elasticstack if Elasticstack also allowed you to edit the Kibana hostname after you've done an install and perform an update. If it doesn't, then then you probably don't need this code, and if it does, then it will have this bug where when you're typing, the status endpoint will come back and just replace it with the old hostname that was there before.
Right. Interesting.
So single-use things that only matter at install time and can't be modified later probably don't have to be part of state because they're not part of the cluster status.
They come back as null from the cluster status endpoint, and we already have a bunch of null checks, I think, for all of those hostname edits. Like they don't update any of your fields if it's null and you've got something in there, I think.
Yep.
And we used to have another bug where it would just clear it out while you were typing it the first time. But that one, I think, got solved in a generic way, while the editing one has to be solved in a specific way for Knative, or just hasn't been generalized yet because of the fact that Knative was the only one doing that, where all the other ones like issue or email, etc., they all have to solve for this problem.
Cool. So I've shown you kind of how to add a GitLab-managed-apps and this upgrade. We can uninstall as well. So if you click the uninstall button, it will uninstall app. It just basically does the same thing in a pod, and it runs Helm uninstall -- purge basically. The only difference is that it runs in a uninstall - application thing. Cool.
So
yes,
I posted this question in the orchestration Slack earlier, and I think I answered my own question, but just to use the brains of everyone on this call. So if I uninstall and reinstall the Ingress GitLab managed app currently, it should, I was trying to figure out why that wouldn't automatically start working again. If I reinstall the Ingress controller, it should pick up the existing Ingress resources, right? I guess the only issue is that maybe if I'm using something like the IP address like nip.io base domain, then it's not going to update the rules set. Is that right?
I'm not sure.
I guess I'm just asking more generally to try and figure out what the relationship is then between the managed apps and the pods for the user's project pods, and if how tightly integrated those are.
Yeah, so that's very Ingress specific. Let's look at Ingress. So there's nothing special here that I can see.
Well, I guess, is it Ingress specific, or would that happen with Knative as well? If you're reinstalling essentially, well, I guess you don't just reinstall Istio, you reinstall the entirety of Knative. So
Ingress doesn't use a CRD. So when you deploy using auto deploy app, you create a resource called an Ingress, which is available, I think, without a CRD. So that Ingress resource should stick around after an uninstall and reinstall of an Ingress controller. Knative would be a different story because that uses a Knative specific CID called a service object, and therefore uninstalling Knative would go ahead and delete your deployments entirely, which would be called service objects in Knative.
Yeah, I suspect it's because the ingress has a rule that doesn't apply anymore because you're using nip.io. So we can kind of peek into that by just going. Oh, which ingress do we want? Interesting. I guess put up. So I suspect it's because the nip.io is, because the nip.io forms part of the host. So if you install a new ingress controller, it's now got a different external IP and so on and so forth, and your this ingress won't match the rules anymore because this part will
So
change.
using like an actual custom domain, then it probably shouldn't be an issue.
I would say so, yes, because the host is the same. That's probably the issue.
Okay. So I guess my last big question on this, and that probably leads to the infrastructure as code like approach, is the more stuff that I've been looking at doing, the more, or for like defend, like the WAF, and another thing we're working on is like intrusion detection, and so that would be like essentially monitoring containers traffic. I think a lot of this ends up being more like sidecars to existing pods or existing charts even. And so I'm trying to figure out exactly where the line is that we want to treat something like a GitLab managed app versus treat something like configuration of an existing resource. And I know that's like kind of a general question, but I guess I'm trying to figure, is there like a general philosophy for what should be a GitLab managed app?
As far as I know, a GitLab managed app is a Helm chart right now. Yep. So if you have a Helm chart that you can install using Helm upgrade -- install, then that's a GitLab managed app. So that's the approach that we're currently taking right now. And you can see there's a lot of code that assumes that we have Helm to install and things like that, right? So it gets a bit harder if it's just if you want to have install just a configuration as a GitLab managed apps, I feel. That makes sense as a thing, and that applies equally to both CI based installation and this GitLab managed apps, this current way of installing GitLab managed apps.
CI based though should be a lot easier when you have lots of things you want to pass into your Helm chart though. So like,
yes,
you don't have to do all the view front end stuff just to pass things in.
Mm-hmm. Yeah. So for the new CI based approach, say we will still have ingress as its own, as its own template. Install ingress as its own template. Install submanager as its own template. Would we then have a different template just to modify the existing ingress configuration? I'm not sure, because then we'll have to figure out, hey, has ingress been installed? If it's not, do nothing. If it is, then we have to figure out what's the existing state of the ingress so that we can modify it. And that's basically what Helm does, really. Does that kind of answer your question? I'm not quite sure what if I'm getting in the right direction.
I think it does generally. I don't have a good grasp on the CI based approach. It's not like kind of a theoretical one. Is that part of our session today? Is going over that, or should?
Yeah, if we have time, I think. Yeah.
Yeah, we have about 20 minutes left. I think it would be worthwhile to chat about that. I think that fundamentally that doesn't change the fact that a GitLab managed app still represents a Helm chart. So, a lot of the logic that we built in the backend can be reused. But I think that there's a more nuanced question, like what constitutes a better MVC, let's say, sort of like for web application firewall. I thought that it was, great. that it was done off of the existing Ingress app. And if that can be done for others, I would encourage that person or group to use an existing app if it makes for a better MVC.
Have we discussed at all using something like Flux to manage applications in a cluster?
Yes, in the sense that I think we discussed this on Slack at some point as well. So it's basically, whether we want to use Flux or something like that to do it in the cluster to pull things in, or we use GitLab CI to kind of install apps into that. And there's trade-offs really. But the main thing for me is that we know GitLab CI, and we can, for the user, it's really easy to read the GitLab CI logs. Versus something like Flux or any kind of in-cluster operator, where we still have the same problem as current GitLab-managed-apps, where we don't know what's going on, and someone will have to manually go in and read the logs from the controller or port or something like that. Does that make sense?
Yeah, totally.
Mm. Okay, so in terms of the CI-based installation approach, I'm imagining the first part is basically a way to have different cluster permissions for different projects. So this is especially pertinent for a group cluster. So for a group cluster, you want most of the projects that can use the group cluster to only have edit privileges for the namespace related to that cluster. So say project 1 would have staging and production. So it will only have access to those 2 namespaces, and then repeat it for n namespaces for all the projects under the group. But with management cluster management projects, you can specify one of those projects under the group to have cluster admin privileges, so that you can use that project to install, to use GitLab CI for that project to install cluster-wide things like Knative or Cert Manager or anything. So anything that requires cluster admin, and that includes GitLab-managed-apps. And how I imagine that we'll implement it is that we'll have a CI template. And the CI template would basically look a lot like AutoDevOps, but it's really installing applications instead, GitLab-managed-apps instead. So inside auto-configure, sorry, that might be a bad name, we can change it. We'll have kind of sub-templates that's composable. This is thanks to James, we discussed this, which is great. A lot of this came from James. In that, if we have auto ingress, Cert Manager, Prometheus installed by default. You can have customizations, I guess. That's probably subject to change. You can also specify if you want more values other than the standard ingress YAML. Oh, not that one. I'll find it later on. So it will include vendor ingress. Oh, not that one. Vendor ingress.
I guess if we prefer to push things into the cluster from CI, have we thought about using something like Terraform to do that instead of rolling all of our own kubectl commands?
We could just use standard Helm, really. Just go Helm install. Yeah, I mean, that's what I'll use in the first instance. And then if that doesn't work, then we'll think about Terraform.
Yeah, it just would give a state.
So does this mean that we would auto-install Helm with a cluster?
I'll come back to that in a minute. Let me just finish this. So basically, what will happen is that this will install these values by default, and then you can specify different values as well if your user say that you want extra annotation and things. Again, as I think, no, maybe we discussed this in the previous call. We don't need to install Helm. We can just go, we can just start up a local tailor. And that's also the same as tailorless, really. So, and then we just need to have the Helm client install applications through the local tailor. And in Helm tree, I think they're folded that we don't even need that local tailor even. So Helm will just install applications based on the Kubernetes configuration that it has access to. So if your Kubernetes configuration has access to cluster admin permissions, then it can install it. If it doesn't, then it will fail probably. Does that make sense, Lucas?
Yeah, it does. I guess. So does this eliminate Runner as a GitLab managed app? How do you run this in the first place?
Yeah, Runner is a special thing. In order to run CI jobs, you need a runner, right? So we're thinking that in the first instance, if you already got a shared runner, then that's fine. Then you can just use this to run. But if the only runner they have access to is a GitLab managed runner on the Kubernetes cluster, then I think you got a chicken and egg situation, right? So that's the first thing. And the second thing is that we also will probably need to find out if it's possible to update the Kubernetes runner using the CI job, right? So it gets a bit weird if it doesn't work. It might break things as well. So imagine we previously installed the Kubernetes runner, and then we say upgrade the Kubernetes runner in the CI job. Do you know what? I don't know what will happen. It might break because it's using the CI job to upgrade itself, and then the runner manager might restart and then it will break, I think, most probably. But who knows? Maybe it works. So runner might be a special case at this point, I think.
So at least currently, you need to provide your own runner to use this approach. Okay.
Yeah.
And is the CI-based approach fully replacing the existing GitLab-managed-apps approach, or are these both going to be supported?
It's going to be the CI-based approach is going to replace the old approach eventually. So we're trying this out, the CI-based approach as an alpha kind of experiment, and if it works out, we'll replace it with the GitLab managed approach. And what we imagine it doing is that we'll still have a UI, but the UI under the hood will be just using the CI jobs.
Okay, so what is a Helm file?
A Helm file? A Helm file is basically so instead of using just bare commands where you go Helm install something, there's a Helm plugin called Helm file. I don't know whether we want to use Helm file or not for this instance, just a clarification. But a Helm file allows you to specify a file that you declare, here are the charts that you want to install, and Helm file will read that YAML file. It's another YAML file to basically make sure that the state of the cluster matches the Helm file. So if you specify that you want ingress as a release, cert manager as a release, then if Helm hub detects that on a cluster you don't have ingress or cert manager installed, Helm file will sync those two and start installing ingress and cert manager. And how it does it is basically it just does a diff. If the diff differs, then it will start installing it or upgrading it. So for example, if the diff differs, it's installed, but you have an older version installed on the cluster, then you'll start installing that version instead. I have a few pipelines here that I can show you as well. So this is a very quick prototype that I made, and as you can see, that's how you call Homefile. So Homefile has detected that I want to install the Ingress release, the Cert Manager CRD release, and the Cert Manager release as well. But it also has detected that there's no diffs, so nothing was affected really. And then if I look in some pipelines, so that's an install. Cool. So over here, Homefile has detected that everything's changed basically. We basically have nothing related to Cert Manager application, so it's outputting the whole diff. Really, everything's new. So because everything's new, it's gonna install Cert Manager. So and then it basically runs installing Cert Manager on that thing. I think Homefile doesn't negotiate the differences. Helm does. So Helm would manage those differences for you.
That's really cool, though. I hadn't seen Homefile before.
Yeah.
That's nice.
Yeah. Yeah, it's pretty cool. But I'm not quite sure whether we need to use Homefile really, honestly. For this part, we can just use Helm install and be done with it. But as a kind of a standard configuration option for someone to check into their project, Homefile might be useful as well, I think.
I think like Helm will manage your state for you of a single release, but if your release disappeared from the repo, Helm won't know to uninstall it unless you run Helm uninstall. So I guess like maybe Helmfile does that, but I don't actually know. Does Helmfile keep an extra layer of state that knows all of the releases that were installed and knows to remove the ones that are no longer referenced?
I don't think so. I think the only state is in the Helm file. So the state where say, it's not really state, it's just a bunch of declarations in the YAML. And if Helm file generates those YAMLs and then detects that it's different from the state in the cluster, then it will run Helm install. And that's it, really. What Helm file also allows you to do is Helm file allows you to have different environments for different Helm files as well. So it reads environment variables as well. So if you got a multi namespace situation, you can install the same ingress differently using different environment variables. I think the state is still maintained by Helm, either by config map or secrets, depending on how you've configured your Helm.
From the docs, it sounds like Homefile relies on you to use it to update. It calls the Homefile YAML the state, and it relies on you to update it. So if you want to remove something, then you need to call Homefile delete to delete a release from the state file. So at that point, it knows that it needs to go to the cluster and do that too.
Yep.
It doesn't look like it picks it up as part of apply.
Oh, really? Interesting. So
what
I managed to do,
modify the YAML and then say apply.
Yeah. So what I managed to do to uninstall is that I just modified the YAML from install true to install false, and then apply, and then it deleted it. Basically, yeah.
Oh, okay.
And from the perspective of our application, it's no different than going Helm install or Helm uninstall. It's just that you can't check in Helm install or Helm uninstall. You can check in Helm file as a declaration of the state that you want it to be. Just quickly, please see. So get config map. So this is the state I was talking about. Sorry, for Helm. So Helm stores the state of your releases inside this config maps. So the name of your chart, the name of your Helm application, .v whatever. So I've upgraded runner, so you can see that there's runner v1 and runner v2 as well. So yeah, that's the only state that we have there for Helm.
Should that be cleaning up v1?
Sorry?
Should it have cleaned up v1?
Doesn't need to. I mean, unless you configure Helm to keep only a certain number of releases. Because this is how Helm will know when you run, say, Helm history runner. It will know that, oh, okay, here are the different versions that it has installed before. It's just a binary blob. I presume Helm knows how to decode this. Ready? Yeah, I don't have access to the TLS cert, so I can't show you Helm. But you know, potentially, but if you go Helm history, that's what allows you. Having Helm v1 and Helm v2 allows Helm history to say, you know, that's the history of it. And probably it probably say superseded for Helm v1, I'm pretty sure. Cool. Yeah, I think we're almost time in 2 minutes. Does anyone have any more questions? Potentially for either the CI-based installation or the current GitLab-managed-apps?
All right, so it looks like we're good. Thank you very much, Stong, for taking the time and walking us through this. And thank you everyone else who attended and for the questions. Have a good rest of your day, all.
Thank you.
Thanks, everyone.
Bye-bye.
See you all.